Imagine a place so dark, so heavy, and so incredibly hungry that even light itself, the absolute fastest thing in the universe, cannot escape its clutch. It is the ultimate cosmic trap. Think of it like a hotel where you can check in anytime you like, but you can absolutely never ever leave. And the room service? It's terrible. It just crushes you into a subatomic soup. We are talking, of course, about black holes. They are the monsters under the bed of the universe, the heavyweights of physics, and quite possibly the most confusing objects in existence. But don't worry, by the end of this video, you'll understand them perfectly, or at least you'll be confused on a much higher, more intellectual level. So what exactly is a black hole? Is it a hole? Is it black? Well, yes and no. A black hole isn't really a hole in the sense of a drain in your bathtub, though that is a popular image. It's actually a massive amount of matter packed into a very, very small space. Imagine taking the entire Earth, every mountain, every ocean, every awkward family dinner you've ever sat through, and crushing it all down until it was the size of a sugar cube. That sugar cube would be so heavy, and its gravity would be so intense, that if you got too close, nothing could save you. That is essentially what a black hole is. A point of infinite density where the universe has effectively divided by zero and broken its own calculator. Now, before we start panicking and building black hole-proof bunkers, we need to address the biggest myth about these guys. Pop culture loves to portray black holes as cosmic vacuum cleaners that wander around the galaxy sucking up everything in sight like a hungry Labrador at a picnic. But that is not how gravity works. Gravity is actually a very polite force. It respects distance. If we were to magically replace our sun with a black hole of the exact same mass right now, Earth wouldn't get sucked in. We would freeze to death, which is a bummer, and we'd be very confused about why it's suddenly dark at noon, but our orbit wouldn't change. We would just keep circling that black hole happily forever. You have to get up close and personal to be in danger. But how do these terrifying sugar cubes form in the first place? They are usually the ghosts of dead stars. Stars are constantly fighting a battle. On the inside, they have nuclear fusion pushing out, exploding with energy. On the outside, gravity is crushing in, trying to collapse the star. For billions of years, it's a stalemate. But eventually, the star runs out of fuel. It's like a car running out of gas, except when a star runs out of gas, it doesn't just pull over to the side of the road. It catastrophically implodes. If the star is massive enough, we're talking way bigger than our sun, gravity wins the arm wrestling match instantly. The core collapses in on itself with such violence that it punches a hole in the fabric of space-time. This collapse creates two main parts of the black hole that you need to know about. First, there is the singularity. This is the very center. It's the point where all that mass is concentrated. It's tiny, it's dense, and quite frankly, it makes physicists cry because the laws of physics as we know them just stop working there. It's the "Here be dragons" section of the math book. Surrounding the singularity is the event horizon. This is the point of no return. It's the invisible line in the sand. If you're swimming in a river near a waterfall, the event horizon is the point where the current becomes faster than you can swim. Once you cross that line, it doesn't matter how Michael Phelps you are going over the edge. In a black hole, once you cross the event horizon, the escape velocity required to leave exceeds the speed of light. Since nothing can go faster than light, nothing gets out. Not your radio signals, not your flashlight beam, and definitely not your screams for help. So what would happen if you actually fell in? Let's say you are a brave, slightly reckless astronaut who decides to take the plunge. As you approach the black hole, you would experience a phenomenon with the greatest scientific name ever invented: spaghettification. I am not making that up. It sounds like a cooking disaster, but it's actually a gravitational nightmare. Here is how it works. Gravity gets stronger the closer you are to the source. If you fall feet first toward a black hole, your feet are slightly closer to the center than your head. Usually, this difference is negligible, but near a black hole, the gravity is so extreme that the pull on your feet is millions of times stronger than the pull on your head. You get stretched, violently. You would be pulled into a long, thin noodle of human pasta. It's not a great way to go, but at least you'd be tall for a fraction of a second. But while you are being turned into spaghetti, things get even weirder for anyone watching you. Let's say your friend is watching from a safe distance in the spaceship. Because black holes possess such immense gravity, they warp space and time itself. This is straight out of Einstein's playbook. To your friend, you would never actually seem to cross the event horizon. As you get closer, the light coming from you would take longer and longer to climb out of that gravity well. You would appear to move in slow motion. Eventually, you would just freeze at the edge, fading to red and then disappearing. To them, you are frozen in time forever. To you, however, time passes normally, until you get crushed, of course. It's the ultimate relativistic ghosting. We also have the heavyweights, supermassive black holes. While standard black holes are the size of a city with the mass of a few suns, supermassive ones are the size of solar systems with the mass of millions or billions of suns. And guess what? There is one right now in the middle of our own galaxy, the Milky Way. It's called Sagittarius, a star. It holds our galaxy together like the hub of a wheel. It's currently sleeping, mostly quiet, but occasionally it burps out some X-rays just to let us know it's still there. It's terrifying to think about, but also kind of comforting. It's the anchor of our galactic home, just an anchor that would eat you if given the chance. For a long time, black holes were just theory. Einstein's math said they should exist, but Einstein himself thought nature wouldn't be crazy enough to actually make them. He was wrong. In 2019, humanity did the impossible. We took a picture of a black hole, specifically the one in the center of the galaxy M87. It looks like a blurry, glowing orange donut. That glowing ring isn't the black hole itself. Remember, you can't see the black hole because it eats light. That glow is the superheated gas and dust swirling around the drain, moving so fast it glows with heat. The black spot in the middle? That's the shadow of the monster. So, do these things live forever? Is the universe destined to eventually become nothing but a dark room full of black holes bumping into each other? Surprisingly, no. The brilliant physicist Stephen Hawking theorized that black holes actually leak. They emit a tiny, tiny amount of radiation, now called Hawking radiation. Over incredibly long periods of time, we are talking numbers with so many zeros you'd need a second universe just to write them down. Black holes will lose mass and evaporate. They will eventually shrink and disappear in a final poof of energy. So, even the darkest, most permanent prisons in the cosmos aren't actually permanent. Black holes remind us that the universe is far stranger, more powerful, and more complex than our everyday lives suggest. We live on a quiet little rock, worrying about traffic and emails, while out there in the dark, dead stars are crushing spacetime into points of infinite nothingness. It's humbling, isn't it? It makes your bad hair day seem a little less significant when you realize you aren't currently being spaghettified into a subatomic noodle. Thank you so much for watching and getting existentially terrified with me today. If you enjoyed this journey into the dark heart of the cosmos, please hit that like button. It helps us escape the algorithm's event horizon. And don't forget to subscribe and ring the bell so you never miss an episode. Stay curious, stay safe from singularities, and I'll see you in the next one.